Hi friends, I am Kajal Munde and welcome to the tutorial series on basic electronics, and the title is Finite State Machines. In this tutorial I will be explaining you about the finite state machine and its examples as a Mealy machine and Murray machine. The finite state machine are the devices that follows the state of sequences in an order which is already defined. It stores the status of something at a given time and can operate on the input to change the status, causes an output to take place for any given change. To summarize it, the state machine can be described as an initial state of something stored someplace, or a set of possible input events, or the set of new states that may result from the input. The finite state machine consists of these two blocks, that is combinational circuit and the memory. The memory is used to store the status of the logic, and the combinational logic circuit, which again includes the two elements which we will see later. The finite state machines are represented by the state notations like state diagram, state table, transition table and excitation table. These are the two diagrams, that is the state diagram and state table. The state diagram is represented by these nodes, vertices and these directed arcs. This node represented by the circle and the name of state is written inside this circle. This directed arc gives the transition from one state to another state, which is the most important in finite state machines. Then this label which is put on this arc gives the input and output, which is separated by slash. Now the state table, it is a tabular form of the describing operation of the circuit. Each row of the state table is corresponding to the state of this logic circuit, and each row is corresponding to the combinations of the input sequences. Now let's take the overview, that is the Murray state machine and Mealy state machines. As there are the two models developing to represent the sequential circuit, we will talk about these two models in depth. One model is the Mealy machine and another one is the Murray machine. The two models we have to see. They are very important if I talk about the state diagram. So what are the difference between these two models? The main question is how they differ each other. They differ in the only where the output is generated in which manner. You already know the sequential circuit. It consists of what? Combinational circuit and memory. And memory block is nothing but your flip-flop, and if you want to calculate the output, it may depend upon the input and definitely the present state. But sometimes it doesn't depend upon the input. In that case, we called it as an Murray state machines. In the Murray state machines, the sequential circuit whose output depends only on the current state. That means the output is the function of only current state. There is no impact of input to the output, or where output is not connected to the input. So this circuit is called as a Mealy machine. Here we will see the combinational circuit, which is also called as next state decoder, which produces the output whatever be the output, and this is given to this output is called as an excitation, and this given to the memory element, where the memory is used to store whatever the output produced by the next state decoder. And one important thing here is the another combinational logic circuit, which depending upon output is to be generated. You can already see that output is only the function of current state. The present state is stored in this memory. Then there is no impact of output to the input, or the output is not connected to the input. So this is called as Murray machine. Now we will consider another model which is called as a Mealy model of the circuit. Now we will see how the output is generated in the Mealy machine and how the output is generated in the Murray machine. This is what the difference between these two models, that output depends on the two different quantities. Now in the Mealy circuit, as same like of the Murray circuit, same blocks are present. Only the output is the function of present state, current state and this present state. So the sequential circuit whose output depends on current state as well as the primary input is called as a Mealy machine. Now let's see one example of the Mealy and Murray machine. Here I want to detect the sequence 1 1 1 on the sequential circuit. We will discuss how the sequence is generated here. Now here I have 3 consecutive ones. So the sequence detector is having the input by which it gives the bit stream, and that bit stream is analyzed by the sequence detector, and it will detect the particular pattern out of it, and if the pattern is detected, then only the output will go high, and definitely there is the clock in the sequential detector depending upon which the detector is works. So the sequence we have to detect is the consecutive ones. So let's say input bit stream is x is equals to 0 0 1 1 1 0 1 1 1 1, and let's take another 0. So what will be the output of the sequence? Let's say output is a y, and it will first detect the 0. Definitely we don't require 0, so output is also 0, and then again it will detect the input 0, making the output equals to 0. Then 1, and 1 is definitely our first bit that we want, but this is not detect whole pattern, so output remains 0 for this input 1. And similarly we are in the queue and we want another one, so output is still 0 because of the we haven't got our third one, and now we have third one over here, and we want the 3 consecutive ones, so now I am having 3 ones, and here making the output equals to 1. So when whole pattern is generated, it will generate the output is equals to 1. But again I am having input 0, so it will produces the output 0. Similarly it will detect all these 3 bits until these 2 bits are not detected the whole sequence, so output is 0, and for this one input it will gives the output high, and it will remains 0 for the 0 input. Now the important thing comes here is the overlapping and non-overlapping. If I consider overlapping, then this one will gives the output, this one will gives the output 1 because the 3 consecutive ones making here, so output is 1, and then the 0 is there, so which will produces again 0 output. But this is when I consider the overlapping. Now we will see non-overlapping. What if I say there is a non-overlapping? Then my output will look like something this, that is 0 0 0 0 1 0 0 0 1 and 0. Here first it will detect similarly as like overlapping, like 0 0 0 1 1. Next when 0 is detected, it will give the 0. Then for this it will detect also 0 0 1. But when this 1 is indicated, it will not consider another previous ones which is already checked, so it will give the output 0, and when 0 is gives, it will also gives output 0. Next step is to find the state diagram, and let's say S0 is my first state and it is actually the reset, therefore S0 is equals to reset. When you switch on the sequence detector, the S0 is only the reset one, and then S1 is considered as an 1. See how the state diagram is represented. Suppose firstly I am on the state S0, and when the input bit stream 0 is coming, then it will remains in the same state because I don't want the 0 as my whole sequence is 1 1 1. But when the input bit stream 1 is appear, then it will go to the next state S1 by making the output is equals to 0. Now similarly as the state S0, I am on the state S1, and when the input bit stream 1 is coming, then it will go to the next state as we want the 1. But when the 0 is coming as an input bit stream, then it will go back to the state S0. Now I am on S2. When the input bit stream 1 is having, then it will go to the next state S3. And when the input is 0, then it will go back to the state S0. Now on S3, now we have S2 state as 1 1. Now I am on the S3, and we again it will give again 1, then it will remains in the same state as our whole sequence 1 1 1 is completed, so output is 1 in this state, and in this present this sequence is present in the state S3. Similarly for this S3, but when the 0 input bit stream is coming, then it will go to the reset state, that is S0. This is what the Moore sequence detector will work. Now we will see how the same example can be run or work by the Mealy sequence detector. Similarly, as a Moore, when the S0, I am on S0, and when the input bit stream is 0, it's remain in the same state. And for the input bit stream 0, for the input bit stream 1, it will go to the state 1. As I get 1, now the S0 state has an 1. I am on the S1. When the input bit stream 0 is considered, then the sequence is 1 0, which is not in our sequence. So when the 0 is coming, then it will go back to this S0 state. Now when the 1 is considered, that is 1 1, then it will go to the next state S2 by making the output is equals to 0. Now suppose I am on S2, and when the input bit stream 0, that is 1 1 0 is coming, then this is not our sequence, so it will remains in the same state, cause 0 is neither for the S0 or S1, so it remains in the S2 state. But when the sequence 1 is represented or input bit stream is 1, then it will go to the next state S0 by making this output is equals to 1. So this is what the difference between the Mealy and Moore sequence detector. In the Mealy sequence detector, when the 0 is considered and there is no sequence or there is no 0 in previous two state, it will remain in the state S2. So thank you.